Hi, this is the second of 5 videos going through the practice exam for 2016. Okay, so looking at question 6, we want to show that sine squared a is equal to a half multiplied by 1 minus cosine of 2a. So that's our part we're going to work on, our cosine 2a. So if we look at our right hand side, we have a half multiplied by 1 minus cosine of 2a. So here we're going to remember here 1 minus, well, our cosine of 2a becomes cosine squared a minus sine squared a. So this one's nice to do. We've got here, we're trying to get to sine squared a. We've got this sine squared a here, and we've got this cosine squared a. And if we remember, well, cosine squared a plus sine squared a is equal to 1. So cosine squared a is equal to 1 minus sine squared a. So if we substitute 1 minus sine squared a into this cosine squared a, we have a half multiplied by 1 minus, here we've got 1 minus sine squared a minus sine squared a. There. So we keep on working through this here. We've got 1 minus, and if we look in our brackets here, we've got 1 minus sine squared a minus sine squared a. So here we have a half multiplied by 1 minus 1 plus sine squared a plus another sine squared a. So here we've got 2 sine squared a. So we've got 1 minus 1 is nothing, so we've got a half multiplied by 2 sine squared a. A half times 2 is 1, is equal to sine squared a, which is equal to our left hand side. So now looking at question 7, we want to expand and simplify sine of alpha minus beta plus sine of alpha plus beta here. So our first thing is to substitute each of these in here. So we're going to have, well, sine of alpha cosine of beta. Remembering minus gives us a minus again. So here we have sine of beta cosine of alpha plus, now here our sine of alpha plus beta is the same thing but with a plus in the middle. So we're going to have sine of alpha cosine of beta plus sine of beta cosine of alpha. So if we look here, we've got minus here and a plus here, so these will cancel out, and we've got 2 lots of sine alpha cosine beta. So we end up with 2 sine of alpha cosine of beta. Now looking at question 8, we're considering our equation sine 2 theta is equal to sine theta. So we think through, our sine of 2 theta is theta plus theta here. So we get sine of theta cosine of theta plus sine of theta cosine of theta. So this becomes 2 sine of theta cosine of theta. So substituting this in, we get 2 sine of theta cosine of theta is equal to sine of theta. We subtract sine theta from both sides. 2 sine of theta cosine of theta minus sine of theta is equal to 0. So now we see we have this sine theta term in both parts of our equation. So we take this out the front. Sine theta is equal to 2 cosine of theta minus 1 here. So now we know either sine of theta is equal to 0, or here 2 cosine theta minus 1 is equal to 0. If we think about our sine curve here at 0, we have sine theta equal to 0. So that's our alpha is equal to 0. To find our general solution, we're going to go through, we have n pi plus minus 1 to the power of n times our alpha. So here n pi plus minus 1 to the power of n times 0. It's times 0, so that cancels out. So here our theta is equal to n pi. So here at 0 pi we're at 0, at 1 pi we're at pi, 2 pi we're at 2 pi. So we can see that one works. Now for our second part. So we've got 2 cosine of theta minus 1 is equal to 0. So 2 cosine of theta is equal to 1. Cosine of theta is equal to a half. So if we draw our triangle here, we've got 2, 2, we split this in half, 1, we've got pi on 3, pi on 6, and root 3 there. So here for cosine theta to be equal to a half, we're looking here, we're going to say our alpha is equal to pi on 3. And then for our general solution, our theta is equal to 2n pi plus or minus our alpha. So 2n pi plus or minus pi on 3. And so these two are our general solutions for this equation. So in this range between 0 and 2 pi, we can clearly see what our results are using our sign. So here we've got 0, pi, and 2 pi. And then for our part here, we can see, well, in our first quadrant, it's going to be pi on 3. We can use either method. We can either think about it here where we've got all stations to central to be positive. It's going to be first and fourth quarter. So our next one will be 2 pi minus pi on 3 is equal to 5 pi on 3. So these are our solutions here. So continuing on to question 10, we want to sketch this function here showing our x and y intercepts and then state our domain and range. So here we're going to draw our axes. Try and use a ruler when you do yours. So here we've got 25 minus x squared. So here our y will be equal to 0 here when our x is at -5 and when our x is at +5. So moving this around here, y squared here, we're going to end up with 5 being our value when we're cutting through our y-axis here. So here we're going to end up with 5 as well. If we look at this, we can see our x can't be any larger than 5 in our positive or negative direction. If we do that, we're getting into a negative number in our square root. So our x must be between our -5 and our +5. Because we have this square root symbol, we know y can never be negative. So it must be greater than or equal to 0. And we know, well, it's restricted by these values here and it can't ever be any greater than 5 there. So here we have our domain and our range.